of a right triangle. First, a few definitions. A right triangle is a triangle with one right or 90-degree angle. In order to determine if it has a 90-degree angle, one trick is to use a piece of paper or a note card and to see if you have an angle that's the exact same as one corner of a piece of paper. So in these three triangles, each of them has a right angle. The right angle of this green triangle is right here. The right angle of the blue triangle is here, this one, and then of the orange triangle right here. And we mark a 90-degree angle with this small box in those corners. The base of the triangle is the triangle side by which the shape is measured or named. So it can be on the side, but most of the time in a book or in a practice problems, you'll see it on the side that it's sort of sitting on. In this case, this would not be the base. The base would be one of these two that's on either side of the right triangle. And then finally, the height is the length of the line segment perpendicular to the base. And perpendicular means that with the base it makes a 90-degree angle. So in this case, here, we would call this the base, and then this side is the height because it makes, with the base, it makes this 90-degree angle. So this side and this side are perpendicular. In the blue triangle, we see we have a short base and a longer height because the base and the height come together to make the 90-degree angle. Now let's see how triangles are related to rectangles. In this picture, I've drawn a geoboard and I've marked off a square with the red rubber bands, let's pretend. And remember that a square is also a rectangle. It's just a special rectangle because all of its sides are equal. So in this case, let's first think about what the area of the square would be. We can figure out the area of the square. Remember, that's a measurement of how much space it takes up, how many square units, by counting the squares covering. This would be 1 square, 2, 3, 4, 5, 6, 7, 8, 9. So the area of this square is 9 square units, or you could also figure that out by doing side times side. 1, 2, 3 on this side, 3 on this side. 3 times 3 would be 9. So we agree that the area of the square is 9. Well, if we take another rubber band and cut the square in half, we've now formed two triangles that are equal in this case. And the area of the triangle, it makes sense if it cuts that square in half, the area of the triangle is going to be half of what the square was. So if the square had an area of 9 square units, then half of 9 is going to be 4 and a half, or you could do 4 5/10 units. And if we wanted to double check that, we could count them. Here would be 1, 2, 3 full square units. This half one plus this half one would make 4, and then there's a half of a square unit right there. So 1, 2, 3, 4 and a half square units. And this triangle up here would have the exact same area. Here's an example on graph paper. We've drawn a rectangle with a length of 4 and a width of 2, and we can know by counting or by using our formula that the area of this rectangle is 8. Let's find it. 1, 2, 3, 4, 5, 6, 7, 8 square units, or we could have done 2 times 4 to get 8 using our formula. And if you drew a diagonal line between the top and bottom corners, you can see that you've now created two triangles, and these two triangles split the rectangle in half. So the area of this triangle and the area of this triangle must be half of the rectangle. Half of 8 is 4. And then again, we can double check that. Here's a full square unit, 2. So I have 2 full square units. Now I'm going to look at the pieces that I have. And I hope you see that this piece right here, if I added it together with this piece, would make another full square unit. And this piece right here, if I added it together with this little piece, so took it and put it right here, it would make another full square unit. So I have 1, 2, 3, 4 full square units, and that is the area of the triangles. Oh, let me show you one more thing before I switch that. It might also help you to see it by cutting. If I have an index card, I could find the area of the index card by measuring its length and its width and then multiplying those using our formula. But if I cut it in half on the diagonal, now we can see that I have two triangles and my cut wasn't exactly straight, but we can double check. I'm going to rotate it now, and you can see that those two triangles fit over top of each other. If I had cut it straight, that would have been exactly right. But that proves that the area of the triangle is equal to half the area of a triangle is equal to half the area of the rectangle. So let's use what we know about how squares and rectangles and triangles are related in order to use a formula or create a formula. So the formula for an area of a triangle, this is what you may see most often, and this formula does the exact same thing, and it's a little bit easier for us to manage. So you might see that the formula for an area is written as 1/2 base times height. So the base of the triangle times the height, and then take half of that. An easier way for us to think about that is find the base times the height, or the area of the rectangle, and then just divide it by 2. Remember that dividing by 2 and multiplying by 1/2 actually do the same thing. So we're going to use both of those formulas in order to find the area of 3 different triangles. So we see here that I have a right triangle. 5 meters is the base, 6 meters is the height. So I've written my formula, and then I'm going to replace the base with a number and replace the height with a number. So the base of my triangle is 5 meters, and the height of my triangle is 6 meters. Now I'm going to do what's inside parentheses first, based on the order of operations. 5 times 6 is 30. And now I can think to myself, half of 30, because multiplication can mean of, half of 30 is 15. So the area of this triangle would be 15 meters squared. On the next one, the base here is longer, and here's the height. I've written this formula to show how it's a little bit easier to manage. Base times height, so the base was 20. I'm going to replace the base, and the height was 10. And then I'm going to do what's inside parentheses first. 20 times 10 is 200. Remember, you can just multiply the 2 times the 1 and add 2 zeros. That's a shortcut that we know. And 200 divided by 2, broken into 2 equal groups, is 100. So the area of this triangle is 100 square inches. Remember, each time area uses square units. And finally, don't let this kind of problem trick you. Notice that they have given you all 3 measurements, but you must know that your area for a formula, the formula for the area of a right triangle, is dependent on you finding the right angle and using the 2 sides that are coming out of the right angle, or the 2 sides that are perpendicular. So you want to forget about this. This length here is called the hypotenuse, the one opposite of the right angle. So forget about that one. Don't let them trick you. And realize that this would be, we would call this one the base and this one the height. So the base is 2 kilometers. The height is 3 kilometers. I'm going to do what's inside parentheses first. 2 times 3 is 6. Then 6 divided by 2 is 3. And the area of this triangle is 3 kilometers squared.